Yep. No, let's try this again. Top of page 88. You have the word compositions. We did this just a little bit yesterday. Is this the right equation? F of x is 3x plus 1? Thank you. And g of x is x cubed. And the first problem that we did was this. Now let's remember what that means. If you read this as f of 3, you read this as f of x. How do you read that? F of g of 2. Now remember, we got our machines. Now our machines are f and g. The question is, how do you know which one to do first? Well, let's look. This says I'm going to do f on what? G of 2. So that means I got to know g of 2 first. Okay? Well, what's g of 2? Well, g of 2 is 8. Good. So this is going to be f of 8. I'm sorry? The machines? You want me to draw those again? Well, all right. I hear you snickering at my machines. I think they look more like a cactus, but a Minecraft cactus. Well, there you go. Minecraft cactus. Okay, both kind of sad, but they'll serve the purpose. Now, which in this setup here, f of g of 2, which one happens first? G. So this one's g, right? And this one's f. Now, so what are we going to g? We're going to g 2, right? So what goes into g is 2. So 2 goes into g. What comes out? 8. 8 comes out. What goes into f? 8. So 8 goes into f. What do you get? 25. 24 plus 1? 25. All right, let's review your number 2. Your number 2 was, we didn't get to number 2. Well, we're going to do number 2 right now. G of f of 2. Same thing? Let's talk about it. Read it. Oh, the two functions, f and g, are the same. Yeah, yeah. Let's read this. This says g of f of 2. What's going to go into g? F of 2. So what machine has to work first? F has to work first. So what's going to go into f? 2. 2 goes into f. What pops out? 7. What's going to go into g? 7. 7 goes into G. He's working really hard because he's got a cute 7. And what comes out? 343. Number 3. Number 3, same functions. F of g of 0. That's a really ugly 0. Which function's going to go first? G is first. What goes into G? 0. 0 goes into G. 0 cubed is 0. What goes into F? 0. That's it. Questions? All right. Now this is kind of the next section of that page, okay? I'm going to give you new functions. I want you to write these instructions. Now, do you notice I put a little open circle? Write it down, and then I'll tell you what it means. Textbooks and math people write compositions in two different ways. I like to write them like this. Some like to write them like this. Ladies and gentlemen, these two mean the same thing. You read this as f of g of x. Most people will look at it and call it fog. Fog is a composition, okay? So if you want to, you can just write above this. This means f of g of x. Fog and golf. What do you think golf means? G of f of x. Oh. The only golf I'm good at is putt-putt. Okay. Now, what number are we on here for you? We're on number 4. I'm going to give you two functions. I'm going to give you f of x equals 5x plus 2. And I'm going to give you g of x equals negative 4x plus 1. Now we're going to find f of g of x, and we're going to find g of f of x. Folks, the minute I see that, I'm rewriting it like this, because that fog business just annoys the crap out of me. So I just rewrite it where I'm not so crapped out. That's a bad term in it. Okay. Now, if we need our machines, what, did you hit yourself in the head? No? Okay, just checking. Slowly deteriorating. Wait till you're 50. Okay. Which function goes first? G goes first. Good. Now, I want you to look at this, and I want you to think, when you see f of g of x, what goes into g? X does. X does. Now, this is going to sound a little weird, so I need you to be careful here. X is going to go into g. What's going to come out? G of x. G of x. But what is g of x? Let me write it like this. G of x is negative 4x plus 1. And f of x was, I forgot, 5x plus 2. If I put x in here to this function, no, I know this just sounds weird, okay? What does this say? That's g of x, right? What is g of x? So this is just going to be negative 4x plus 1. That's right, Gavin. That's right. That's right. See, in this machine, you're not changing what's already there, are you? Nothing's changing. X stays X. Now, when negative 4x plus 1 goes into F, what in the world happens? What gets kicked out? The X gets kicked out, and what gets put in its place? So, So here's how we're going to write this confound thing. I know that everywhere in F that you see in X, I'm going to put negative 4x plus 1, right? So what's that going to look like if I put negative 4x plus 1 right there? Now, do you see what we did there? In this F, we kicked out the X. That's gone. And this is put in its place. So it's 5 times that plus 2. And yes, and I heard the word distribute. Go ahead and distribute. What are you going to get? Negative what? Negative 20x plus 5 plus 2. Now there was one other. Why are you not writing those down?
What's the point? I mean, I'm already.
I lost my whole train of thought. Oh yeah. At the top, when you wrote your directions, it said find f of g of x and g of f of x and the domain. Folks, what's the domain of negative 20x plus 7? What in the world? What in the world? Why, Kentha? Because what? If you graph negative 20x plus 7, you're going to get a line. What's the y-intercept? 7, what's the slope? When you got a line, now look, that line, let me do this. Negative 20x plus 7, y-intercept is 7, slope's 20, that sucker's real steep, isn't it? What's the domain for a line? All real numbers. What's the range for a line? All real numbers. So the domain and range of this all real numbers. I want to show you another way to write this. In Algebra 1, you might have done set notation. And I just want to remind you what set notation looks like. I'm not fond of set notation, to be completely honest with you, but now and then it comes in handy. Not on these. I just want you to see what it looks like. All real numbers looks like this. All x such that x is an element of the real numbers. Okay? Okay, fine. Fine. I'll give you that. Judd said XLXER. I don't know what word that spells, but it's a good acronym. No. Hey. She already told me. Okay, now we've got to do, I'm going to erase all this mess here. We've got to do g of f of x. If we're going to do g of f of x, g of f of x, which one comes first? F comes first, and then g. Now remember, f is 5x plus 2. G is negative 4x plus 1. What goes into f? X. Does anything change when you put x in there? No, we're kicking x out and putting x back in its place, so nothing changes. So what comes out here? 5x plus 2. What's going into G? 5x plus 2. What's getting kicked out? The x. And what's getting put in its place? 5x plus 2. Good. So this is going to be, how are we going to write this? Negative 4 times 5x plus 2 plus 1. There you go. Negative 20. Come on. Negative 20x. Good. Minus 8 plus 1 is minus 7. That's real close to what we got the other time, isn't it? What's the domain? All reals. What's the range? All reals, because when you graph that thing, that would be a line. That would be a line. For a line, yes. Well, you look at this. What's the biggest exponent you see? A 1, right? When you see an x to the first power, that means linear. It's 1, okay? The only line that does not have domain and range of all real numbers is a vertical one. A vertical one. Because it doesn't use every x value. It only uses one x value, okay? All right, let's move on. Blah, 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 blah. Next question. I'm going to give you f of x equals square root x. And I'm going to give you g of x equals 2x. We're going to find f of g of x first. If you need to draw the machines, you are absolutely welcome to draw the machines, but that takes some time. Can you think through the machines without drawing them? What goes into G? X. So that's just 2x, right? What's going to go into F? Yeah, so I'm going to do it like this. What comes out of G? 2x. What goes into F? 2x. So in F, what do I boot out? X. What gets put in its place? That's it. Yep. Yep. Let's talk about the domain for just a minute. What does the square root look like? Do you remember? Do you remember that a square root? A square root looks like this. Now this has something done to it. Do you remember what that 2 does to it? It's a horizontal what? Horizontal compression by a factor of 1/2. Woohoo! Horizontal shrink by a factor of a half. This starting place doesn't change though. What's the domain? Where? 0 to infinity. Well done. Well done. Domain is 0 to infinity. Well done. Let's do g of f of x. Okay, let's think through it without doing the machines. What function happens first? F. What's going into F? X. So what comes out? Square root of x. What's going to go into g? Square root of x. So I want you to write like this, g of square root of x. Good. So in g, what gets booted out? X gets booted out, and what gets put in its place? Square root x. So what's that going to look like? 2 square root of x. Good. Good. The parent graph is square root x. How's that 2 change it? How's that 2? Vertical stretch by, good, by a factor of 2. Well done. So we know that thing's just going to go kind of like that. Same domain. Good. 0 to infinity.
Explain how that works.
Explain how what works, sweetie?
What you just did, because.
You mean
Like,
the graph or you mean the work? Okay. What part did I lose you on?
well, if it's g of x, so why would it, and then you're supposed to like take the x out, so why would it just be the square root of x?
We're going to make fast machines here. I know.
That one looks cute.
They look like a plant, of water, the water plants.
Yeah, that's
You see that? Of course.
better than the mine.
Which function is going to happen first? F, and f of x is square root x. G of x is going to happen second, and that is 2x. Okay? Now, right here, what goes into f? Just x. So nothing's going to change, is it? Because that is f of x. So what's going to spit out here? So what goes into g? Square root x. And that's why I wrote this. Square root x is going into g. Okay? That goes in. And remember, it kicks the x out and replaces with this. So 2 times the square root of x is what's going to kick out. Is that any better at all, Trin? Okie dokie. We just have one more pair of problems, and then you're going to have the rest of the period to work. All right. Last one.
What if we ran out of room on our page?
Well, if you ran out of room on your page, I could give you a sticky note and let you do the last problem there. One more. One more. F of x equals x squared. G of x equals negative 2x plus 5 over 4. That is a big one. Yep, we're going to find f of g of x first. All right. What function happens first? G. Well, what is g of x? It's this. So what's going into f? This, right? So write it like this. F of negative 2x plus 5 over 4. Now I want you to write it the way I'm writing it, okay? Now, this mess right here is going into f. There's f. This mess is going in and it's kicking out what? X and substituting itself. So, what's it going to look like? Yeah, itself squared. And you can leave it like that. I do not have a problem with you leaving it like that. Yeah, really. Talk about the domain. Here's something I want you to know. You don't have to write this down. A polynomial We've been working with polynomials ever since the first day. A polynomial could be a monomial, a binomial, a trinomial. Remember all those? Any polynomial has exponents that are positive integers. I'm just going to put it like this. Positive. No, I'm going to put it like this. Let me do it like this. The exponents are like this, okay? You cannot have an exponent that's a fraction. You cannot have an exponent that's a decimal. If you've got a function where all the exponents are numbers like this, then the domain is always all real numbers.
No way.
Always. The domain is always all real numbers. Now you say, well, this didn't have a domain of all real numbers. No, it didn't. Do you remember how we rewrote that with an exponent? Is 1/2 one of those numbers?
No, it's not.
Nope. That's why it has a different domain. Okay. Wait, what? What? No, we good? Okay. What's the domain of this thing? What's the exponent you see right here? With that x? 1. What's the exponent you see right here? 2. Are those good exponents? Yes. What's the domain? All real numbers. Domain is all real numbers. If the only exponents you see are 0, 1, 2, 3, 4, like that, your domain is all real numbers because it's a polynomial. Now let's do g of f of x, and we are going to be done with teaching for the semester.
Wow.
Okay.
You're flipping it.
I am flipping, not kidding. G of f of x.
We got a quiz on Friday, right?
All right, here we go. What happens first? F happens first. What is f of x? X squared. What's going into g? X squared. You're going to write that, yeah, f of x, which is x squared. So you're going to write it like this. So I'm going over to old g, and I'm kicking x out. And what's being put in its place? X squared. So what am I going to write down? That's it. That's it. Domain. What exponents do you see? 2. 2. What's the domain? All real numbers. Ladies and gentlemen, your quiz is going to be over inverses, combinations, and compositions. All right? You have got, now today's a short class period because of RTI. You got 40 minutes. 40 minutes. You are to do the back of the paper you did last night. Okay? Let's go. Play again.